welcome back to my channel. If you haven't subscribed it yet, please subscribe and kindly see the video in 720 pixels. Okay, let's dive into the today's topic, the microstructure of the breast tissue. What's the overview of this? Yes, the microstructure of the breast tissue varies with what? The age. Here I have added some points for you to remember the topic. If you read it, you might be able to remember it. The age, the time of the menstrual cycle, the pregnancy and lactation. Tell it with me. The age, the time of the menstrual cycle, pregnancy and lactation. So how to remember these points? So the microstructure of the breast tissue varies with age. Imagine on the breast there's a clock and it's shifting gears throughout the life. And like the moon, it waxes and wanes with the menstrual cycle. So it gives the microstructure changes. And with pregnancy, picture a baby or a flower on the breast. You might be able to remember it more. And lactation, think of lactation as a river flowing and ducts expanding inside the breast. Now you can actually see the mental image for you to remember the topic. So the next one, the duct structure. There are ducts and there is myoepithelial cells. So the ducts, they are lined by the columnar epithelium. Like a column of books in the library. Columnar epithelium. Say it with me. Columnar epithelium. Then the larger ducts, they're lined by two layers of columnar cells. It's like a two-story tower. Then smaller ducts lined by single layer of columnar cells or cuboidal cells. Say it with me. Smaller ducts lined by a single layer of columnar or cuboidal cells. Then those 3 points are for the ducts. So it is lined by columnar epithelium, larger ducts lined by two layers of columnar cells, smaller ducts by the single layer of columnar or cuboidal cells. Then the myoepithelial cells. They are ectodermal origin, similar to the other glandular epithelia. So how to remember this? Picture a seed sprouting from the skin, growing into specialized myoepithelial cells. That's ectodermal origin. And those myoepithelial cells located at the bases of the columnar or cuboidal cells. So visualize it as the foundation of the house. Okay, so the columnar or cuboidal cells is there and the myoepithelial cells are below. They act as a foundation. Then those myoepithelial cells are numerous beneath the epithelial lining, forming a distinct layer. So these myoepithelial cells forms a epithelial lining. Okay, so beneath the epithelial lining they form a distinct layer. Now these myoepithelial cells, they surround both the ducts and the presumptive alveoli. Those are myoepithelial cells. They surround both ducts and the presumptive alveoli. This myoepithelial cells, this gives the epithelium a bilayered appearance. Say it with me. It gives the epithelium a bilayered appearance. So you can use these. What I have added to remember it. For others, if you're not familiar with that, you can just study this part. That would be enough. Then the lactiferous ducts, they drain each lobe of the breast. So think of doors opening from each room, from each lobe to drain the milk through these ducts. So the lactiferous ducts have 3 points. What? Drain each lobe from the breast, pass through the nipple, open onto the nipple as 15 to 20 separate orifices. It's like separate 15 to 20 puzzle pieces. That's lactiferous ducts. So the lactiferous sinuses. Near the orifice, the ducts are slightly expanded into lactiferous sinuses. In lactating breast, these sinuses are further dilated by the presence of milk. In lactating breast, these sinuses are further dilated. How to remember this? Imagine the sinuses as balloons, swelling when filled with milk, swelling when filled with milk. Then the ductal system. Each lactiferous duct is connected to a complex system of ducts and lobules. Each lactiferous duct is connected to a complex system of ducts and lobules. Think this entire system is surrounded by connective tissue stroma, collectively forming lobe of the breast. So the ductal system have 2 points. What? Each lactiferous duct is connected to complex system of ducts and lobules. It's like spider web. Okay. Next point is entire system is surrounded by connective tissue stroma. So that forms the lobe. So that's about the lactiferous ducts. We have discussed about the overview, the duct structure, and the lactiferous ducts. Then the lobules. Important. The lobules, they consist of portions of the gland that have secretory potential. Imagine each lobule as a wrapped gift ready to be opened for secretion. So it's like a wrapped gift. It will open and it will give you the gift. The structure of the lobule varies depending on the hormonal status. Like a roller coaster, the lobule structure changes with hormonal ups and downs. Like the moon comes up, goes down. In the mature resistant breast, each lobe consists of a cluster of blind-ended, branched ductules. In mature resting breast, each lobe consists of a cluster of blind-ended, branched ductules. How to remember this? Picture these ductules as tree branches with no leaves. The termini of these ductules lack mature terminal alveoli, those are acini, which are the sites of milk secretion. So in the mature resting breast, they lack the acini. So when they lack acini, they can't produce milk. So it's like an unfinished business. That's about the lobules. Then the nipple epithelium. It's a stratified cuboidal. And near the openings of the lactiferous ducts is replaced by keratinized stratified squamous epithelium. Continues with the epidermis. So it continues with the epidermis. They are stratified cuboidal, but near the opening of the lactiferous ducts, we have keratinized stratified squamous epithelium because it is continuous with the epidermis. Then shed squames may sometimes block the duct apertures in the non-pregnant breast. In non-pregnant breast, those shed squamous cells may block the duct. Now, the next part is the nipple structure. So internally, the nipple is mostly composed of collagenous dense connective tissue. Then, internally, numerous elastic fibers which cause wrinkling of the overlying skin. Deep to the nipple areola, bundles of smooth muscles are there. How? They are arranged radially and circumferentially. Those smooth muscle cells are thought to be remnants of the paniculus carnosus. What is that exactly? Is a part of the subcutaneous tissue in vertebrates. You don't have to remember it. Just remember the term, that would be enough. So deep to the nipple and areola, the last point, the smooth muscle fibers contract in response to cold or tactile stimuli. So 3 points regarding the deep part of the nipple and areola. You have numerous elastic fibers, and there are smooth muscle cells which are arranged radially and circumferentially, and the smooth muscle fibers contract in response to cold or tactile stimuli. Okay? Right, that's nipple structure. Then we are going to the connective tissue in the breast. So the lobules and the ducts are surrounded by connective tissue stroma. The stroma consists of fibrous tissue and fat cells. Then what we have to remember is in the resting breast, the connective tissue stroma is relatively dense. In resting breast, the connective tissue stroma is relatively dense. Then sentinel node identification. Sentinel node. What's the sentinel node? Well, that's the first node where the lymph drains into. So sentinel nodes are typically located in where? In the low axilla at level 1. The metastasis to these nodes occur in some breast cancers. In cases where sentinel nodes are involved, axillary completion, dissection or radiotherapy is offered. So, how to remember this? When the sentinel nodes is infected by the metastasis, when you have identified it, you have to use radiotherapy or the complete dissection. Skip metastasis to higher level nodes occurs in 5 to 10% of the cases. So what happens is the cancer comes at one point, it skips the sentinel node and goes to the other one, goes to the other lymph node. So that's the skip metastasis. Now the next point. The occasional sentinel nodes are found on extra-axillary locations. Where? Extra-axillary locations are where? Within the breast parenchyma. Internal thoracic lymph nodes and supraclavicular fossa. Within the breast parenchyma, internal thoracic lymph nodes, supraclavicular fossa. If sentinel nodes test negative for metastasis, the morbidity associated with axillary dissection can be avoided. If sentinel nodes are negative for metastasis, the morbidity associated with axillary dissections can be avoided. What a beautiful topic. Now, we have come to the end of this lecture. We'll see you soon on the next lecture. Thank you for joining the session. Thank you very much. Goodbye.